Hello, and welcome back to another episode of Layer by Layer. Today we are going to be looking at these two holder blocks. I use these basically in the makerspace that I help run. I use these at home, at work. And the way they work is this is a print-in-place design. There is a locking screw here. If you insert a screw and rotate it 90 degrees, what it does is it takes this little locking knob here and rotates it and locks it in place. This is designed to lock onto a piece of 15mm DIN rail. So DIN rail comes in two sizes. Normal is 35, but they also make a miniature version of it that's 15mm. And to give you an idea of what it looks like when it's all together, this is a picture of my lab at work. I have basically all my screwdrivers laid out. Each of them uh, has a label so that I can know exactly which driver goes where. So let's go and take a look at it in CAD to see how this is designed. So I have the CAD open up here. So let's talk a little bit about the print-in-place mechanism first. So this whole part is printed in one go, and when it's done, you pop it off the print bed, you stick a square nut in the back here, and you stick a M3 by 8mm socket head cap screw in here. And once you tighten it and give it a quick twist, this breaks loose and it's basically a captured part. You don't actually have to assemble this. This actually comes off the printer with the moving part already assembled. So how that is achieved, and by the way, the reason for inserting the screw and nuts into the same piece here is to give it a little bit of rigidity and also to provide a way for you to turn it with a screwdriver. That's the only reason why there's a nut and screw going into the same part. So how is this print in place uh, 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 achieved? Well, I'm basically taking advantage of the fact that on a 3D printer, you can print up to a 45-degree overhang without supports. And so this piece here with this 45-degree overhang and the surrounding piece being cut away to, with a gap in between is how this print-in-place mechanism is achieved. And so if I were to let's spin the cat around a little bit more. You can see that I'm using polygonal approximation again to close off this bore left by the square nut, transitioning into the shaft for the M3 screw. And if I were to hide that lug, you'll see that same thing here. This is used so that I can close off this area without support. So the way this works is this, by the way, this part is designed for 0.2mm layer heights. So all of these features, if I were to measure from here to the build plate, these distances are all integer multiples of 0.2mm. So the way this works is, let's say the slicer is coming along, it comes to this surface here. It's going to perform a bridging operation across and a bridging operation across here. Now with these two bridges done, at the next layer, 0.2mm away, so if I were to measure that distance, that's 0.2mm in difference. So the next layer, it's going to come across and it's going to bridge across this way and it's going to bridge across this way. And then by the time that's done, I would basically have the this area squared off. And so on the next layer, if I were to advance to the next layer, printing this circle, the only thing, the area that is not supported is this area that is this very small tangent corner here on all four sides. And so you are able to do counter bores and things that have an opening quite easily with this technique. So anyway, and then finally, this is also done by a bridging operation as well. So let's take a look at it in the slicer to see how that actually comes together. So this is the part in the slicer. And then, as you can see, slicing at 0.2mm here, we can zoom in a little bit. And then we can see that the square bore for this is for the M3 square nut. And right there, that's where the first bridging operation happens, second bridging operation. And by then, this circular bore is pretty nicely supported by the bridges. Same thing here, first bridging operation, second bridging operation going this way, and then the circular bore, and also the bridging operation that goes across to join the two halves together. Switching back to CAD real quick, you will notice that, by the way, the CAD is going to be shared out. You will notice that the geometry for the block is split into two. If I were to suppress this folder, you'll see that this is the actual clip that handles the print in place and the clicking, locking into the 15mm DIN rail. This here, if I were to unsuppress it, forms the rest of the tool block, label holder, and basically the opening for the tool. So I labeled it so that if you're to make a copy of the CAD files and you want to make this for your own tools, you're welcome to do so. I think that's all I have for this one. So if you like what I'm doing, please like and subscribe, and see you next time. Peace.